Hello everyone. Sorry for being absent for so long. There were a lot of projects I had to complete and there were plenty of distractions as well. However, I'm not coming empty-handed. Last year I started working on a Binary and Hex course and today I will present what I have so far. Binary and Hex calculations are used more and more, and you may find them not only in computer code but also in OBD, onboard diagnostics, communications, serial decoding for LIN and CAN buses, and calibration parameters. However, existing binary and hex courses are geared towards college and university students specializing in computer science and coding, and would not be too helpful for people with other backgrounds. So, my attempt to tackle binary and hex is to consider real-world applications for binary and hex and introduce mathematics on the need-to-know basis, at the same time trying to make use of online calculators as much as possible. I have worked with members of Diag.net and collected their feedback on what works and what doesn't. I covered a range of topics from OBD Mode 1 and 6 data to programming EEPROM chips. It took a huge effort to put all of this together, but let's take a look at what I have so far. To start with, let's go to my website arithmechanics.com/software/awesome. This is where I store my online data processing apps, but also at the bottom you will find the tab for courses. I have 9 modules in total. The first 3 for binary and hex, just the basics. And then I have 3 modules devoted to EEPROM. And then finally, 3 modules devoted to advanced topics such as proprietary CAN bus communications, emulated EEPROM, and reverse engineering CAN bus data. In binary and hex module 1, you will find introduction of what binary and hex are, how to use online calculators to convert those numbers, and then we tackle mode 1 data coming through an OBD port and interpret that data. Module 2 builds up on module 1. It introduces signed integers, and then it allows us to analyze mode 6 data. In module 3, we learn that we can transmit not only numeric data, but also text data over, let's say, CAN bus. And we show how this can be done for transmitting VIN, vehicle identification number, over CAN bus. Also, we learn what ASCII coding is and what canonical hex plus ASCII display is. As we talked previously, the next 3 modules are devoted to EEPROM, and the first module explains why EEPROM is very special type of memory and what limitations of it are, and why we need error detection, error correction, and error leveling when working with EEPROM. We also look at real-world examples how VIN and key data are stored in EEPROM, as well as how odometer values are encoded in some of cars. Now, the next module is actually introduction into Python, and why I had to include it is because the next module talks about how to program a microcontroller to communicate with an EEPROM chip, and the easiest way to do that is by using MicroPython. And so this Python primer is unlike others. It focuses heavily on working with binary and hex numbers, while most other introductory courses are focusing on how to print hello world. So it's different. It's lengthy, but I had to include it so that you have all the information you need for the next module, which, as we talked, is exactly programming in EEPROM using MicroPython. And the EEPROM chip here is 93C66B, and the microcontroller is the popular $4 Raspberry Pi Pico. And so we go in how we communicate with the EEPROM chip. We look at its datasheet and create a library of how we can read any location we want. Now for the advanced topics. In module 3, we looked at how text data can flow over CAN bus, but we looked only at the example of onboard diagnostics, OBD communications, which are heavily standardized. For proprietary communications, things can be similar but different. And here I introduce an example of how it's done for GM cars. So we look at what CAN IDs GM cars use, what requests look like, and what responses look like, and how we can extract VIN from a module. And I use a real-world example, just a BCM communicating over a CAN bus, decode all that in Picoscope and see for myself what information we can find in that communication. The next module, also advanced, looks at what flash memory is and how it can be used to emulate EEPROM. For that, we need to introduce a lot of concepts about how flash memory works, page and sector sizes. But at the end, we will be able to look at what happens sometimes to BMW's FRM modules where memory can get corrupt and how we can go and try to recover that data. And last but not least, it's a topic that I see appearing on YouTube channels very often. How do we look at CAN bus data and decipher what's happening? And you know, there is a method that gives good results most of the time, especially for numerical data. And this is what I'm presenting in this module. I'm using Python to make all the calculations easier and more effective. And for the example, I'm using steering wheel angle sensor data for a GM car. We set up a Picoscope to capture 5 to 10 seconds of data, move the steering wheel around so that we have something to work with. And then we dive in and see what kind of packets there are, how to filter the ones that we are interested in, and how to omit the ones that we are not interested in, how to look at the bytes in the packets, try to interpret it as the data, and then finally plot the results and say, hey, this really looks correct. This is our steering wheel angle data. So this is pretty much the syllabus for this humongous course. There is many hours of recorded video for this course. And I put a huge effort into making it what it is right now. So I'm presenting it to you. You can get it on this website. And what you are getting when you are paying for this course is not just the videos. You're actually acquiring some living project, because what you will be able to do is to watch videos and then ask questions. I will see questions that you ask under the videos, and then we'll have follow-up meetings over, let's say, Zoom, where we will discuss your questions and discuss related topics, maybe dive deeper in certain topics. Also, based on your feedback, I'm totally open to re-recording some of the videos, improving them, adding some answers to some of the questions, or maybe adding new material. So this is a lot of effort from me, but also I hope that it will be very useful to you. And so I'm able to provide this living project of a course on Binary and Hex for $300, or Canadian customers will pay 330 Canadian dollars plus whatever Canadian taxes are, depending on the province where you are. And you get all 9 modules. The payment is done over PayPal, so you just press the right button, send the money. Ideally, you will get access immediately. However, there could be some delays with how fast PayPal sends the payment notification to my website. So maybe there could be some delay of 1 day or so. Hopefully, this will be an easy process. Once you have paid and the website was notified, then you will have access to all the 9 modules. What they are, let's take a look. So after the payment was recorded, the next time you go to the web page and click on the module, instead of the payment information, you will see the actual page with videos and other information. So first thing, there will be a reference page which contains some tables that are referenced along the way. So you will always have access to that. Also, you will have the link to the video itself. And then there will be information on the next presentation where we will discuss your questions or dive deeper into the material. So for example, the next presentation for Binary and Hex Module 1 will be 28th of June, 8 p.m. EST. And there is a Zoom meeting link and password how to connect there. If you click on the video, it will open a new page where you can watch the video. You can scroll anywhere you want. And also, at any point in throughout the video, you can ask a question. For example, just type in and then click submit. And it will submit your question and record a timestamp. So I know exactly when you ask that question, what kind of slide it was considered at that point. So it will be very convenient for me to see what you see when you are asking that question. And hopefully this works on all computers. I tested that on the Firefox, iPad, Android tablets. Hopefully it will work on your computers, but if it's not, you can always contact me. You see that this link over here with contact, and tell me if you are experiencing any issues. And this is pretty much what you have for each of the modules in the bundle. You'll have a reference page, you have a video link where you can also ask questions, and you will have a presentation date when you can join me on Zoom for up to half an hour meeting and ask questions and get more training. So this is it for now. I hope this course will be useful to you, and to make sure that you understand the level of presentation and what kind of material you are likely to hear, here is 5 minutes from the Binary and Hex Module 1. Enjoy. USB and the PCM connected using a CAN bus through an OBD port. So in reality, it looks like this. We have an OBD cable connected to this ELM327 device, and then a USB cable going to the computer where I can type in commands and the car will reply some hex data that right now for us looks like gibberish. But hopefully by the end of the presentation, we will be able to make sense out of this. So some simple commands for ELM327, just a short overview. ATZ will reset the device and the device will print a greeting saying that it's ELM327 version 1.3a in my case. ATRV will request a battery voltage, and in my case it will report at 12.4, so I have a good power right now. Obviously the key is on and the engine is off, so that's the battery voltage. ATSP0 is a command to select auto protocol. Remember that in OBD port you can have several connections, and it might decide to use CAN bus, or it can decide to use, let's say, K-line or something. In my case, I'm pretty sure that selecting this auto protocol will actually use CAN bus for communication. And now comes the interesting part. I'm sending a command 0100, which corresponds to requesting mode 01 data, PID 00, which corresponds to getting a list of supported PIDs for this car. And after a little while, I get back 6 bytes that we need to interpret right now. So how do we do that? So when I'm sending 0100, I'm getting back 6 bytes. Remember that each byte is 2 hex digits. So the first byte is 41. It's actually the mode 01 with 0 replaced with 4 to indicate valid response. So that's how the PCM says, I'm replying to mode 01 data and the response is valid. The second byte is just a repeat of the PID, which is 00. But the next 4 bytes, we need to interpret as a list of supported PIDs. And how we do that? We actually need to convert each byte into binary and then use that binary digits as a bit mask to figure out which PIDs are supported and which ones are not.
So let's start with the first byte, BE. So we convert B into binary 1011 and E into binary 1110. And then what we need to do is to write under each binary digit the names of the PIDs starting from 01H. So 01H, 02H, 03H, 04H, and so on. And in the places where we have zeros, it means that the PID is not supported. And where the digit is 1, it means that this PID is supported. So this means for our car, the PIDs 01, 03, 04, 05, 06, 07 are supported, but PIDs 02 and 08 are not. And that's how you interpret this byte BE, and you just do the same thing for other bytes. Convert them into binary.